This is number 32 from chapter 6, section 2 in the back of your book. It reads, are the following processes exothermic or endothermic? Now notice we don't have to calculate anything here. We just have to identify the direction of the heat flow. First example, A, the combustion of gasoline in a car engine. Anyone who's ever opened a car hood or a truck hood after the motor's been running for a while can attest to the fact that a lot of heat is being released by the combustion of that gasoline in that motor. Heat is moving from the combustion, from the combusted gasoline, the hydrocarbon, and it heats the metal that makes up the car engine. So when you open that hood, there's a bunch of heat radiating outwards. Okay, so this process right here is exothermic. Okay, heat is going from the gasoline into the surroundings, which in this case is the motor, which makes the motor very, very hot. B, water condensing on a cold pipe. Now, a lot of students have trouble with this because it's the same substance. It's water in both instances. The only difference is that we're starting in the gas phase and moving to the liquid phase. So the question is energy going into this molecule or is it going out of the molecule? And the easiest way that I've found to wrap my head around this is look at the gas form and the liquid form of these identical chemicals here and think which one is the highest energy version of water. The gas is going to be the highest energy version of water. All right, much higher amount of kinetic energy present in a gas molecule than in a liquid molecule. So we have a high energy form of water moving into a lower energy form of water. And so in order to make this transformation happen, this high energy form of water has to get rid of some amount of energy in order to make this transformation possible. So this water is going to be releasing heat, going to get rid of heat. So that makes it exothermic. A lot of people get mixed up because they think, okay, gas water, water vapor, something hot, steam, is cooling off. And in order to cool off, you absorb coolness. Well, that's a misconception right there. We're just tracking where the heat goes, where the energy goes. So we want to keep in mind which is the higher energy version of water and which is the lowest. On to C. We have a very similar problem here. Oh, I think I have a typo right there. That should be CO2. But we have solid CO2 moving into gaseous CO2. And so, again, we're going to ask the same question of ourselves as we did in C. What's the more energetic version of the CO2? Well, the gas version is going to be more energetic than a solid version for sure. So we have a low energy carbon dioxide being transformed into a high energy form of carbon dioxide. In order for that to happen, this CO2 has to absorb heat, has to absorb energy. Okay, so the CO2 has to gain energy from its surroundings in the form of heat. And so heat is flowing into the carbon dioxide, into the system from the surroundings. That makes this process endothermic. And lastly, we'll look at D. And what we have here, if you don't understand it at first glance, we have fluorine gas, okay, with a diatomic molecule. And then we have the same number of fluorine atoms, but each fluorine atom is completely individual. Okay, the bond that binds the two fluorine atoms has been severed. Now, if you remember your diatomic molecules, Brinkelhoff, the reason that they exist as diatomic molecules is because in that form, they have the lowest potential energy of any other arrangement. Lowest potential energy. So in order to break that fluorine-fluorine bond, energy has to be added in order to break those bonds. We have to add energy. Add energy in order to break the fluorine-to-fluorine bond. And so what we have to do, we have this fluorine gas, and we need energy to move into this system. Flow into this system from the surroundings. Again, in the form of heat. In order to sever this bond. That's the only way you can sever the bond between two fluorine atoms to yield two separate fluorine atoms. So as a result, we can figure out this process right here is endothermic. Energy is moving into the system.